Hey guys, so today I want us to go through questions on parallel and perpendicular lines. It's come up in both exams for 2017 and 2018, so that's November and June. Highly likely to come up again in 2020. Almost all the questions appear in paper 1, apart from one question, I believe in November 2018 was in paper 2. But these are at a minimum worth 4 marks, so a lot of marks available. But they all do follow the same technique. That means if you understand this question, if you understand a few of the questions, you get really all of them. So let's jump in. Let's try and do this question here. Okay. ABCD is a rectangle. That means we have 90 degrees at all these points. Why is that significant? Well, I know with parallel and perpendicular lines, I know that at 90 degrees, we must have a perpendicular line. That means that the gradients are related to one another through this flip and change, this negative flip and change. What do I mean by that? Well, what I mean is that if I give you a gradient of 1/2, then to make the perpendicular gradient, I would have to flip a half, so 2/1, and then times it by minus, or the same thing as -2. Likewise, if I gave you 3/7, I flip this to get 7/3 and times it by -1, so -7/3. So what we're doing is we're flipping and times it by -1. That's how we find out the perpendicular lines. Okay. So we're also told that A to E is equal to E to B. So A to E, this part here, is equal to E to B. These are of the same lengths. Why is that important to us? Well, that means that if we know what coordinate B and E are, then we can find out what coordinate A is. And we're going to need to know what coordinate A is because we're going to need to figure out what this line M is. And the way we're going to figure out what the line M is by knowing its gradient and a point that it passes through. So we know that every line equation is of the form y equals mx plus c. M is this gradient here that we're trying to find, and c is the y-intercept. Now, to find this y-intercept, we need to know the gradient, and we need to know a value of x and y. So we need to know a coordinate. We need to start by finding the gradient for the line L. So line L has the equation x plus 2y equals 12. To find what the gradient is of this function, of this line, we need to first off rearrange it for y equals. So we can take away x from both sides to get 2y is 12 minus x, and divide both of these by 2 to get y equals 12/2 minus x over 2. This is the same as 6 minus a half x, or 6 minus x over 2. I want you to think of it this way here. I want you to think, instead of thinking of it as 12 minus x all over 2, if you think of it in terms of this way, you'll realize that we can immediately put this in the form mx plus c. In this case, our m value is just what's being multiplied by the x, and that's the 1/2, or the negative 1/2 to be more precise. Okay, so we know that the gradient of line L is now minus 1/2. Okay, so let's write this all down. So we can say the gradient of line L equals minus 1/2. The gradient of line M, to find the gradient of line M, we just do what we did earlier. We say we flip it, so you flip minus 1/2, you're going to get minus 2/1, times it by a -1, and that just becomes a plus. So in other words, this is just 2. So the gradient of line M is 2. Now we know that the equation, the form of line M is y equals 2x plus c. So now we're trying to find out what this c coordinate is. Okay. To find this c coordinate, we need to know a point, and namely we're going to need to find A. Okay, so to find A, we're going to use the fact that AE is equal to EB. we can use this equation x plus 2y equaling 12 to find out the coordinates E and B, because we know that at B it has 0 elevation, or in other words, y is equal to 0. Likewise, at E, we have 0 direction in left or right. That means the x coordinate is 0. Now, from there, we can sub both those values. So we can sub in, let's say we'll do B first. So at B, we're told y equals 0. If I put y equals 0 into x plus 2y equals 12, I'm going to get x plus 0, 2 times 0 is 0, equals 12, which means x equals 12. So this coordinate at B is 12, 0. Likewise, at E, so at E, we're told x equals 0. That means from the equation x plus 2y equals 12, that 0 plus 2y equals 12, or 2y equals 12, which means y equals 6. So here we have y equaling 6. So how can we use that to find A? Well, this is just saying 0 to B, O to B is 12 long, and O to E is 6 high. If A to E is the same length as E to B, then I need to do the same direction. So I need to go 12 across, and then I need to go 6 high. So 12 across from 0, 6, so this point over here, would give me minus 12, 6. Then I add 6 in the y direction, and I'm getting minus 12, 12. So now we know the coordinate of A, so we can say A is the point minus 12, 12. We already know that y equals 2x plus c is the gradient, is the equation of the line M. Now we have the point minus 12, 12 that lies on this line. We can relate them together. So now we can say that y, which is positive 12, sorry. So we can say 12 equals 2 times minus 12 plus c. So 2 times minus 12 is minus 24. So 12 equals minus 24 plus c. Add 24 to both sides, and we're getting 36 equals c. Therefore, our final equation for the line M is y equals 2x plus 36. Okay, let's try this next question here. So this one from June 2017, also worth 4 marks. So we need to find an equation for the diagonal A to C. So this line here. We're told already that D to B, going from D to B, has the equation y equals 1/2 x plus 6. Okay. And we're given the fact that at A, we know the coordinates are 5, 11. So like last time, we're given a coordinate now. In order to find the line, the equation of the line A to C, we need to know its gradient. You can probably predict here that these two lines here are going to be perpendicular to one another. This is going to be in 90 degrees. If you're not sure why, if you want to see why that's the case, then we can think about it like so. D to C and C to B are the same length. Likewise, A to B and A to D also the same length. That means all these angles, that means what we have here is we have an isosceles triangle going from D to B to C, and the same isosceles triangle going from D to A to B. So in other words, what we know is that this angle is the same as that angle. And moreover, this angle is also the same because they're the same triangles. Okay. Well, by the same reasoning, we can look at the triangle ACD, so this triangle that goes like that, and we can compare it to the triangle ABC, and we can say the same thing, that this is another isosceles triangle where AB is equal to BC. So these angles are the same as one another. So this angle here is the same as this angle, and by similar triangles, this angle here is the same as the angle over here. Okay, that now means that we have this CB, this point here in the middle. So this point we'll call it O. This point COB, this triangle C to O to B, must mean it's the same for C to O to D, D to O to A, and A to O to B. These are all the same triangles. So they must, at the center, all meet at 90 degrees. Okay. That's just a long way of saying that these are perpendicular lines. You wouldn't have to prove this in your exam, but that's just the justification for it. Okay. Maybe we remove some of this cluster here. So all we're saying is that we're going to try and find this line A to C, and we're going to know that they're perpendicular. Okay. So how can we begin? Well, we can spot immediately from the equation y equals a half x plus 6 that the gradient of this, so the gradient of the line D to B, which is this y equals half x plus 6. Let me put that in green instead, so you can see that a bit clearer. That equation has gradient 1/2. Since they're perpendicular, since A to C is perpendicular to D to B, the gradient of A to C is equal to the negative reciprocal. So flip it, 2/1, times it by -1, you're going to get -2. So that means the equation is of the form y equals negative 2x plus c. We already know that a coordinate A is 5, 11. We're told that in the question. We're told in the question that this is 5, 11. So we can sub in this point here. So that's x, that's y. We can sub in this point to say 11 equals negative 2 times 5 plus c. That means 11 equals negative 10 plus c. Add 10 to both sides and we're going to get c equals 21. So what's the final equation here? Well, from here we can just say that y equals negative 2x plus 21. And we're done. Okay. This next question is a little bit different. We're not given a diagram here. We're just told to find the intersection. We need to find the intersection between these 2 points, between these 2 lines, L2 and L1. Okay, we're given that L1 goes through these 2 points, 4, 6 and 12, 2. And we're told that line L2 goes through the origin. Let's do L2 first because it'll be easier to follow. If the gradient is -3, then we know it's y equals negative 3x plus c. But it goes through the origin. What does that mean? Well, let's think about this graphically. If we have something that goes through the origin with gradient -3, so -3 would mean that it's going in this direction. And since it's going to pass through the origin, it must go through this point over here. So that is going to look like this. Well, what's the y-intercept? Well, the y-intercept is just this coordinate here, 0, 0. In other words, we know c equals 0. So line L2 is just equation y equals negative 3x. And you can do this in general, guys. Every time you see a question that says it passes through the origin, that's just another way of saying c equals 0. So you can just immediately write y equals -3x. You wouldn't need to justify it. You can just say because it passes through the origin. Okay. What about line L1? So L1, that has coordinates 4, 6. Okay, so let's draw another graph for our line L1. So L1 goes through 4, 6. So 4 could be over here somewhere, 6 will be over here somewhere. So we're getting that point over there. And 12, 2 is going to be somewhere over here, too high. So we're looking to find the point, we're looking to find that equation. Well, how can we do it? Well, in order to know the equation, remember, we need to know what the gradient m is. So we have mx plus c, y equals mx plus c. M is just going to be the change in y divided by the change in x. So the difference in the y's divided by the difference in x. That's going to be, the difference in the y's is going to be 6 take away 2, 6 take away 2, divided by 4 take away 12. And it's important you do it in the same direction to not avoid to avoid any minus errors. So 6 minus 2. So 6 minus 2 is 4. 4 minus 12 is minus 8. So this comes out to be minus a half. So the gradient of line M is minus a half. Another way you could have thought about this is just to say, well, we're moving in this direction from 12 to 4, so that's going to be 8 across. And then we're moving up from 2 to 6, so that's going to be 4 up. So the gradient here is 4 over 8. That's another way you can think about it graphically. Okay, and then since it's going downwards, since it's going from top left to bottom right, we go in this direction here, it must be a negative. Okay, so now we know y equals negative a half x plus c. How do we find out what c is? Well, we're going to use one of the points, 4, 6 or 12, 2. We can use either one. I'll just use 4, 6. So we're going to say 6 equals negative a half times 4 plus c. Negative a half times 4 gives us negative 2 plus c. So what does c equal here? We'll add 2 to both sides. C equals 8. So now we have that L1 is of the form y equals negative a half x plus 8. Okay, so how are we going to find out when these two lines intersect? Well, these two lines are going to intersect when they're equal to each other. So really what we have here is we have a simultaneous equation. We can do this by substitution, so we can say, well, negative 3x, which is the y which is y, equals negative a half x plus 8. If we add a half x to both sides, so this side here is going to become negative 2.5x or negative 5 over 2x equals positive 8. Times everything by 2, we're going to get negative 5x equals 16, and then divide by minus 5, that gives us x equaling negative 16 over 5. What does y equal? Well, we can sub it back into either equation 1 or equation 2. We'll sub it into equation 1 because that's just nice and simple. So equation 1 says y equals negative 3 times 16 over 5 times negative 16 over 5, sorry. Negative times negative gives us a positive. 16 times 3 is 48. So this is 48 over 5. So what's the coordinate of P? Well, the coordinate of P is just negative 16 over 5, 48 over 5. Okay. June 2018, paper 1. This one here is worth 5 marks. A little bit more to it because we've got some algebra involved now. We need to find an expression for B in terms of A, and we're told that A and B are these coordinates on the line P to Q, on the line that is perpendicular to P to Q, sorry. So if we're told let's start by drawing out some a graph here. Three x plus 2y equals 7. So we need to find out what the y-intercept is and then what the gradient is. We'll rearrange this for y equals, so we get 2y equals 7 minus 3x. Divide everything by 2, and we get y equals 7 over 2 minus 3 over 2x. This is the same as just 3.5 minus 1.5x. That means we have a negative gradient. So we have a gradient of negative 3 over 2. And we're going through the point 3.5. So this is our c value. That's our m value. So c would be over here somewhere. M would be negative 1.5. So that would be going in the downwards direction. So it would look something like this. This is the line perpendicular to PQ. So if it's perpendicular, that means that somewhere they're going to meet at 90 degrees. So if 3 to 4 could be over here somewhere, let's just say P was over here at 3, 4. Then they're perpendicular if they cross at 90 degrees here. So we're going to need to know the fact that the gradient of this line 3x plus 2y equals 7, so this gradient here is m equals negative 1.5. So negative 3 over 2. That means the gradient for this line P to Q, so Q could be, let's just say Q's over here somewhere, AB. This gradient P to Q is going to be the negative reciprocal of minus 3 over 2. So the gradient of PQ equals 2 over 3. But we're also told that these coordinates are 3, 4 and AB. That means we can use the fact that m is the change in y over the change in x. So what is the change in y? Well, the change in y would be b minus 4 all over a minus 3. Like last time, make sure you do it the same way around, otherwise you risk getting it wrong. So b minus 4 over a minus 3 is equal to 2/3, this gradient of PQ. So now we're saying find an expression for b in terms of a. It's saying rearrange this equation to get b equals. So we can solve this by cross multiplying. So we times that up to there and the 3 up to there. So we're going to get 3b minus 12. So 3 times b minus 3 times 4 equals 2a minus 6. 2 times a and then 3 times 2. We can add 12 to both sides and we get 3b equals 2a plus 6. So plus 12 minus 6 is plus 6. Divide everything by 3 and our final answer is b equals 2a over 3 plus 6 over 3, which is 2. Or you can even leave it as 2a plus 6 all over 3. Both answers are acceptable. Okay. Now we're moving on to Spec 1, Paper 1. Okay. So find an equation of the line that passes through C and perpendicular to AB. So we're given A is over here and B is over here. We need to find what that gradient is. We can do it nice and simple by the graph because it's going 2 across and it's going 4 up. So the gradient would be 4 over 2 or 2. And we need to find out a line which is perpendicular now to this and that goes through C. So if it perpendicular would look something like this and it would go through at 90 degrees here. Going through C, which is the coordinate 5, minus 1. If the gradient of a to b, so gradient of a to b is 2, then the perpendicular to it, so the perpendicular gradient would be the negative reciprocal. So flip it. So think of this 2 as being 2 over 1. If you flip it, you get 1 over 2. Put a minus in front. So the perpendicular gradient is minus a half. That means that the line that goes through C, so the line that passes C, the line that passes C is of the form y equals negative a half x plus C. Don't confuse this C. Don't confuse the C here with this point C at 5 minus 1. These are different values. This is a coordinate. This C value in this equation, minus half x plus C, is just a constant that we're trying to find. But we're given already that the coordinate at C is 5 minus 1. So we're going to sub that into here. So we're going to say minus 1 equals minus a half times 5 plus C. Okay, so that's using the fact that C is the coordinate 5 minus 1. To solve for C here, I'm just gonna times them by 2. I'm going to times all these values here by 2. So times that by 2, times that by 2, times that by 2. So I get negative 2 equals negative 5 plus 2C. Add 5 to both sides, I get 3 equals 2C, or C equals 3 over 2. So the final equation, so putting it all into one, putting it into this equation over here, we get y equals negative a half x plus 3 over 2. All right. This question is a little bit tricky. I've drawn a graph already for us so you can see a visualization of what's going on. Whenever you're given a circle, you just need to know that it's going to go through, it's going to be something centered at the point 0, 0. So it's going to be centered here. And we need to use the fact that we have a tangent line. So if you remember from circle theorems, something that is tangent is going to be touching it exactly one time, like so. And when it's tangent lines to the point at the center, it is 90 degrees. So there's a 90 degrees angle met here. We need to try and find out this line L. So we need to try and find this line L, this blue line L. And we need to find the area of OAP. And P, we're told, is the coordinate where it crosses the x-axis at this point over here. So that's P and that's O. So we need to find the triangle O to A to P. So that's going to be the triangle that goes through like this triangle here. All right, how can we do that? Well, we can recognize that we just need to find the height of this triangle. So that point there, the height there, and then the base. The base is just going to be this O to P. So fortunately, we already know the height of this triangle is just 6, because it's 6 high. So it's up to the coordinate A. Now we need to find what the length O to P is. We've got to find out how we can get this coordinate at P. To do that, we need to know the equation. Right, since we know that O to A is perpendicular, the line O to A is perpendicular to the tangent line L, we can use the fact that this part here, so from here to here is 2. That means the gradient of O to A, so the gradient of OA is equal to 6 over 2, or 3. Now they're perpendicular to one another, which means the gradient of line L is going to be a negative reciprocal. So remember that's 3 over 1. You flip it. So we're going to get 1 over 3 and times by minus. So minus 1 over 3. So the gradient of line L is minus 1 over 3. So line L is of the form y equals negative a third x plus c. Before we can try and find the coordinate p, we need to first off know the coordinate c. So we need to find out the value of c. So we need to find what this value here is. How do we do that? Well, we use the fact that we know that the line L goes through 2, 6. So we can say that at 2, 6, we know we can sub those into the equation. So we can sub y into there, and we can sub in x into here. So we're going to say 6 equals negative a third times 2 plus c. Like last time, I'm going to times everything by 3 here to make our life easier, so we don't have to deal with fractions. So 18 equals negative 2 plus 3c. That means 20 is equal to 3c, or that 20 over 3 is equal to c. So line L is y equals negative a third x plus 20 over 3. All right, why is that useful to us? Well, how are we going to find that coordinate p now? Well, remember, p is going through the x-axis. If it's going through the x-axis, that must mean that the y-coordinate is 0 because it has no elevation. If it has no elevation, we can say 0 equals negative a third x plus 20 over 3. We can add a third x to both sides, so we're going to get a third x equals 20 over 3. These over 3s are going to cancel, and that just leaves us with x equaling 20. So the gradient so the coordinate at p is 20, 0. Okay. That means, okay, that we can say that O to p now, so O to p is 20 long. We already know that it is 6 high. So the area of OAP, triangle OAP, is 20 times 6, base times height, all over 2. Right? The area of a triangle is half base times height. 20 times 6 all over 2. This is the same thing as 20 over 2 is 10. So we can cancel that out, that 2 there, and that 20 there to write it as 10. 10 times 6 is just 60. And so we're done. And if we want to leave our final answer, we can leave it as 60 units squared. We're not given a unit, so we'll try it as 60 units squared. All right, guys, that's everything on equations of lines that we can see. Hopefully you have a much better understanding of how to tackle them. Hopefully you're more confident now going forward into the exam. If you still need them help, feel free to send me a message and I'll do my best to get back to you. Thank you very much.